Hello, Algebra 1, and this is a video review for our Chapter 3 test. And I'm starting off with an equation to solve because we will continue to solve equations all throughout the year. So we want to stay fresh on this always. So first of all, we are going to use the distributive property. Distribute, and just a reminder to try to keep those equal signs lined up and work down the page. -3 times 2x, -6x. -3 times -4 is +12. 5 times x plus 5x, 5 times -7, -35. Not doing anything to the right. It has nothing that is necessary over there. On the left, we are going to now combine like terms. Don't want to do anything until we combine like terms and tidy up this left-hand side. A -6x and a 5x gives us a -1x. A +12 and a -35 gives us 35 minus 12, that is a -23. Equals 3x plus 10. Now that we have everything done on the left-hand side that we can do, now we're going to start moving things across the equal sign. So first of all, think about it. Normally, we want to keep all our x's on the left and our constants on the right. So the first thing I am going to do is add 23 to both sides. A -23 and a +23 cancels to give me -x equals 3x plus 33. And then last, subtract 3x from both sides. We're trying to get all the x's on the left-hand side. A -x and a -3x is a -4x equals 33. And notice my equal signs lined up coming down the page. And then last thing to get the x all by itself is to divide by a -4, which is going to leave us with x equals 33 over -4, squishing that on the very bottom of the page there. And that fraction is just fine. Leave it just like it is. Next, we've got some domain and range questions. And first thing I see here is we got some arrows on either end. But we have a defined beginning at that particular point. So what are the coordinates of that point? That is back 3, up 4. So the coordinates of that point are -3, 4. So if we're looking for the domain, and the domain is red from the left to the right, we have a defined beginning at x equals -3. So that means our domain values are going to be everything greater than -3, because this is going to the left, or excuse me, this is going to the right forever, and this one is going to the right forever. So our domain values, x is greater than or equal to a -3. Now, as far as the range, this graph is going up forever, and it is going down forever. So if it's going up forever and down forever, that means our range is all real numbers. All real numbers. Every single number you can think of is going to be included in this range value. And remember, the range values are the y values. Domain values are the x, range values are the y. Is this a function? Well, if I were to look at those two particular points, it looks to me like if we were to make an XY chart for some of the points that we can see on this graph, we see that -3, 4 is on that graph. We see that 0, 2 is on that graph. 0, 6 is on that graph. And right away, this presents a problem right here in terms of being a function, because 0 is mapping to 2, 0 is also mapping to 6. So is this a function? No, because a function in a function, every single input maps to one and only one output. And we can see here that 0 is mapping to 2 and 0 is mapping to 6, so it is not a function. So here's another graph to consider the domain and the range. So this one's an interesting looking graph. And let's first start by labeling this point right there. That is -3, -3. So if we were starting here on the left, that is the leftmost point. So our domain is going to start at -3. Remember, the domain is all about the x-axis. So x is greater than or equal to -3. Greater than or equal to -3, because this is going to the right forever and again to the right forever. So that's our domain. Now, what is our range? Our range is limited this time. If we look at our range, here's the bottom of our range, and here's the top of our range. The range is limited. The range is all about y. So if this is the bottom of the range and this is the top of the range, and then we're going to include everything in between, the pink highlights there are showing you what our range is. Remember, the range, that's the y values. So y is between. So between what? Well, what do we have right down here? We are starting at -3 and we are going up to and including +4. And all y values in between. So -3 is less than or equal to y, which is less than or equal to 4. Y is in between -3 and +4. The in-between values. It is limited. Is it a function? Well, once again, if we were making an XY chart and just looking at a few points here, it looks like 0 maps to -3, 0 also maps to 4. It looks like 1 maps to -3 and 1 also maps to 4. So if 0 maps to 2 places, 1 maps to 2 places, and we can see this particular graph failing the vertical line test over and over and over. So is this a function? No, because the definition of a function says that every input has one and only one output. Next, we also have graphing from a chart on our test tomorrow. So sometimes the domain is given, sometimes it is not. It's blank here. So when it's blank, we have to think about, well, what are some good possible values for x? Some good possible values for x here, being that we have to substitute it into this function, the g function. The first thing we have to do is divide it by 4. So if we were to put in 3, if we wanted to find g of 3, that would be 1/4 of 3. That would be a fraction. So maybe that wouldn't be a good option. Better options would be multiples of 4. So consider what we're going to put in here. So how about let's put in -4, 0, 4, and 8. I think all of those will fit nicely on our graph. So let's find g of -4. That is going to be 1/4 of -4 minus 2. So follow order of operations here. So 1/4 of -4 is -1, and -1 minus 2 is -3. So that gives us a point, -4, -3. Let's do it again with 0, which is always the easiest thing to plug in. So 1/4 of 0 minus 2. 1/4 of 0 is 0, and 0 minus 2 is -2. So that yields the point 0, -2. Let's substitute in 4. G of 4. Remember, we're just evaluating the function here. So 1/4 of 4 minus 2. 1/4 of 4 is +1. +1 minus 2 is -1. So 4, -1. Finally, the 8. G of 8. That's 1/4 of 8 minus 2. 1/4 of 8 is 2, and 2 minus 2 is 0. So 8, 0. So there's 4 points that is going to help us graph this linear function. So back 4 down to 3, and then over 0 down 2, over 4 down 1, over 8 up 0. So here is our graph of our function using the chart. And you can see this is a function because every input has exactly one output. And also remember, after we plot those points, we are going to connect them with a smooth, continuous line or curve. In this case, it is a line. And yes, this is a function. We also have arithmetic sequences on our test this week. So here's an arithmetic sequence: -10, -6, -2, 2, all the way to a sub n. Remember, a sub n represents any term in the sequence, any term in the sequence. So first thing we want to do is, what is our a sub 1? A sub 1 is the first term in the list, and it is -10. Our common difference here is just found by subtracting -6 minus 10, or 2 minus -2. We'll do that one. So 2 minus -2, this a sub 4 minus a sub 3 gives us a common difference of +4. So we're adding 4 every time. Yes, our sequence is increasing here. So having a sub 1 and d will allow us to write any term a sub n. But you must know the formula for a sub n. The formula for a sub n is a sub n equals a sub 1 plus n minus 1 times d. This is a must know for tomorrow's test. So now all we've got to do is plug in our a sub 1 value and our d value, and we'll have it in expanded form. So a sub 1 is -10 plus n minus 1 times the d, which is 4. So this is an expanded form. We can easily simplify this by distributing the 4 and then combining like terms. I'll move to the right. So -10 plus 4 times n is 4n. 4 times -1 is -4. -10 and a -4 give us a simplified a sub n of -14 plus 4n. So now, if we want to find the 44th term, all we have to do is plug in 44 into our formula. So a sub 44 equals -14 plus 4 times 44. 4 times 44 is 40 times 4, which is 160, and then plus 16 more, that's 176. So -14 plus 176. We have a 44th term in this sequence. -14 plus 176 is 162. Positive 162 is the 44th term. Last problem, evaluating a function. Remember, a function is nothing more than a set of instructions telling you what to do with an input value. So we're going to substitute in 6 everywhere we see x, and then we're going to follow order of operations and simplify. So -1/2 times 6 squared plus 4. We will simplify the exponent first. So 6 squared is 36. So -1/2 of 36 plus 4. -1/2 of 36 is -18. And -18 plus 4 is -14. The value of the h function when x equals 6 is -14. It's just a simple evaluation. Let's do the last one. Let's evaluate the h function when x equals -10. Our function says square first, then multiply by 1/2. So Negative 10 squared is 100. Half of 100 is negative 50, or excuse me, negative half of 100 is negative 50. And negative 50 plus 4 is negative 46. So, ladies and gentlemen, those are the highlights of Chapter 3. I'll see you in class.